To determine the electron pair geometry and molecular shape of BF3, begin by drawing a Lewis diagram. Refer to the periodic table of elements to find the number of valence electrons in each atom. This molecule has a total of 24 valence electrons, 3 electrons from boron and 7 electrons from each fluorine atom. After drawing the Lewis diagram, count the number of valence electrons in the molecule and compare that value to the calculated number of valence electrons to confirm the correct diagram was drawn. Given that there are 3 electron groups around the central atom in this molecule, the electron pair geometry is trigonal planar. Since the electron groups around boron are all bonding pairs between fluorine, the molecular shape is the same as the electron pair geometry. Also, the bond angle for this molecule is 120 degrees. This is a ball and stick model of BF3. The electron pair geometry and molecular shape is trigonal planar with a 120 degree bond angle. Notice that all bonds reside on the same plane. Now, let's figure out which types of bonds are present in boron trifluoride. Refer to the periodic table of elements to find the electronegativity of each atom. Boron has an electronegativity of 2.0 and fluorine 4.0. Fluorine, being more electronegative, will have a greater attraction to the electrons than boron. This is shown by fluorine having a partial negative and boron having a partial positive. Finding the electronegativity difference between fluorine and boron will assist in determining which types of bonds are present. When referring back to the possible bond types, this molecule has polar covalent bonds. Although there are polar bonds present, the polarity of this molecule cannot be assumed as polar. To predict molecular polarity, begin by drawing dipole moments for each bond. Dipole moments show the direction of the greatest electron density. Start the arrow at the positive end and draw the point of the arrow towards the negative end of the bond. To determine if this molecule has a net dipole, add the vectors together. Begin by drawing the first vector, paying attention to the length and the orientation. Then, continue by drawing the second vector, starting from the head of the previous vector. Continue to draw vectors until all are used. If the head of the final vector is located at the tail of the first, then no net dipole moment exists, and the molecule is considered nonpolar. As the bond dipole moments cancel, BF3 is nonpolar.